Hi, everybody. Welcome to the afternoon sessions. We're going to be getting started here momentarily. This session is titled AI at the Edge of Live, Real-Time Intelligence for Language Production and Signal Processing. My name is Andy Beach. I'll be moderating the current set of sessions that we have coming up. Anybody that has questions, there are QR codes that are around the room. There's also one, I believe, that's up there. That will take you to the real-time question answer section. So if you have a question, you can, for the paper, it'll put it there and we'll get to it, at the end of their presentation. Let's get started. Our first speaker is sorry, I did it. Tejaswi, oh, so close. Mulagada. She is a technical project manager and AI strategist with over 9 years of experience in software development, cloud solutions, and AI-driven automation. She's currently at AlphaCord Media Group, where she leads the integration of maintenance, advanced broadcast systems for clients like Fox Media, Yes Networks, and is utilizing technology such as SMPTE2025, Ebert, Lewo, and IABM Cerebrum to enhance automation and signal routing. We're going to listen to her present her paper now.
Thank you, Andy. Hello, everyone. Welcome to SMPTE Media Summit. It's so amazing to be here among so many brilliant, talented media tech minds. I'm honestly so overwhelmed to be in this room. I hope everyone's having fun. Let's get started. Hi, I'm Tejaswi Mulagada. I'm a technical program manager at AlphaCord Media Group. And today, I'm going to take you on a quick but fascinating journey on leveraging multi-agent AI to make SMPTE 2110 broadcast workflows a whole lot smoother. So let's turn broadcast chaos to control. So let's start with a confession. How many of you had battled latency spikes during a live production event? Yeah, I mean, I have done it and I've lost count on how many times it happened. So the truth is zero latency doesn't exist. Why? Because in IP-based video setups, we're sending millions of tiny data packets across the network. Sometimes they bunch up, they arrive out of order and take a scenic route through your switches. So that's what we call jitter, bursty traffic. And what does it do? It creates delays. So that's what our multi-agent AI architecture does. It looks at network patterns in real time, dynamically adjusts the buffers, and keeps your live feeds from looking like a buffer video from back in 2008. So here's what makes it harder. Metadata desynchronization. Your data and your video drifts apart. Like the captions and your video in the movie, they don't sync up. Or buffer overflows. Too much of data rushing into your systems and your systems cannot keep up. And configuration drifts. Small changes that slowly throw your entire system off balance. So historically, we relied on manual fixes, alerting alarms, engineers catching these issues before they happen and try to fix them. So much stress to the engineers. So that's why AI. We move from reactive firefighting to proactive orchestration, predicting the issues and fixing them before they actually hit the network. So these are the known bottlenecks we are dealing with today, the metadata tracking, configuration management, and queue buffers. Every broadcast engineer has fought these, often at the worst times possible. So we built an architecture with AI agents specialized to tackle each of these problems with individual agents. So let's get into the actual architecture itself. So here is how it works. Imagine 3 AI experts working side by side. So we have 3 expert agents And above all of them is your LLM orchestrator. So this acts like a conductor, like orchestrating entire other agents. It helps delegate the tasks between the agents, interpret the results, and also communicates in logs or plain English, however the operator wants the logs to come out as. As a result, automated monitoring while still keeping humans in the loop. So let's dive a little bit deeper. The metadata agent, what does it do? It checks for malfunction packets or format mismatches. So our agent uses ML models like isolation forest and autoencoders to catch anomalies. It looks at thousands of samples per second and keeps false positives under 4%. When it comes to buffer agent, it predicts network traffic spikes and smooths them out in advance. For example, one of the agents, it uses a predictive analytics tools like the one we use for TenorFlow. So it forecasts the traffic burst and automatically, dynamically updates the traffic and also cuts the latency by up to 40% in simulations. When it comes to the configuration agent, it monitors all the devices, spotting misconfigurations before they cause any failures. And the configuration uses graphic maps, a graphic algorithm, like imagine a network map, to find and fix the misconfigurations within the systems that are interacting with each other. And with this, we get a 99% accuracy within the configuration management. And on top of everything, the LLM orchestration, what it does, it delegates and reasons with everything and gives us simple, auditable, and human understandable logs and messages back. So now the key point so that the AI doesn't run wild is keeping human in loop. We built this governance around EU AI Compliance Acts and also IEEE ethically aligned guidelines. So every recommendation is cross-checked by other models, and every final action requires a human validation for critical operations. In case the AI fails or hesitates, the system automatically falls back to SNMP, or your workflow, it falls back to SNMP so that your workflows don't break. As I like to say, AI won't replace engineers, but engineers using AI will. Coming to the comprehensive evolution framework, we just did not design this architecture. We tested it rigorously across different test beds, I used different synthetic samples to test this. We benchmarked latency, false positives, recovery times, and all using ML tools like Scikit-learn. And the results lined up with independent Cisco and Intel studies. Always a really good sign. Coming to the competitive analysis, let's see how it stacks up compared to the benchmarks versus the baselines. Our multi-agent AI achieved 40% faster recovery, fewer alarms, and less engineering stress. Here is the proof. Here are some of the numbers. The latency dropped by 25 to 30%, and the false positives down to 2 to 5%. Configuration self-recovery up to 95%, and the overall mean time to recovery downtime was 40%. So, honest question, would you trust a system that can self-heal 95% in a reliable production environment? I would, especially on a Friday night live stream. Coming to the resilience and explainability. Resilience is about surviving chaos gracefully. And so we added adversarial testing, basically throwing weird, noisy data at the systems to see how it reacts and how it breaks, And from there, how the LLM recovers all the data, all the breaking data we gave it. And the explainability is every AI decision logs are rational. Like, it's very clear, all the logs are auditable, and they align with SMPTE standards. So if something changes, we just don't know why. We also know what is causing the change as well. And coming to the future roadmaps, next up, we're actually building a real-time explainable XAI dashboard. Think of it as a mission control system for operators. It validates to reduce cognitive lead by up to 30%. We're also integrating new standards, SMPTE into SMPTE 2010-30 for audio and also the R148 mappings. And expanding it into new domains, not just into broadcast, but also sports telecasting, IMFQC, OTT ad insertions. So basically wherever the packet flows, and AI can help there. Coming to industry partners, we're not just running lab tests, we're actually partnering with broadcast engineers to deploy this into live broadcast production environment so that the LLM can learn and get better before we actually implement this into real time. That means real data, real constraints, and real wins. We're also contributing to SMPTE standards, so these tools aren't just clever, they're compliant and interoperable. It's not just a research, real pilots in progress. So from chaos to control, our multi-agents make broadcast automation scalable, explainable, reliable, and a lot less stressful for the engineers with better latency. So quick question to you all. Where's everyone in your AI journey? Are you guys just getting started, or are you deep into implementations? I would love to learn more about it. And yeah, that's a wrap. Thank you so much for your time and curiosity. I would love to connect, and whether to collaborate or to talk more about this topic. I'm a nerd about Buffer. Come see me, and I'll take any questions now. Thank you.
Thank you. Were there any questions for Tejaswi? Well, thank you very much for the talk. I really liked, in particular, the piece around resiliency and using AI agents for red teaming. I think that's a very smart move.